Hi everyone, welcome to our 18th session, of the quadratics course, right? So this I was catering for around 20 videos, but it seems that it'll definitely be more than 20 videos. But hopefully I'll finish off with it already. The idea, I believe, I will post up both all the videos individually and also one entire video with all of these merged together. So if it is anybody want to go through these consecutively, they could, or they could watch individual videos if you need it, right? So, um, but yeah, this is the 18th video. So if you're unsure how we went from here to here, drop back a couple videos. If you're unsure about factorization in general, go back a good few videos that have so much content here that you all could learn from, right? So please feel free. You all at the end of this series are going to be able to teach yourself quadratics. Good. So, last video we would have done just some examples on completing the perfect square. Now in this one, we are not going to do any easy examples as we did in the last one. So if you're unsure about perfect square and completing the perfect square, you should go back 2 videos to see where this formula came from and how we use it. So in this video, we are still on completing the square, right? So complete the square of, right? So the first one, and we're starting off with a harder one now. Let's go with 2x squared minus 7x plus 4. Right? So in this one, what you all are going to learn is how to deal with fractions as they come into this question. Right now, remember, and you can write this down as a little tip on the side. Always complete the square on only the x terms. Don't use this constant term. Leave that outside. Right? So we want to complete the square on these terms here. So I usually put those in square brackets. Right? Now, on the terms in x, factor out the constant in front of x squared, factor out e. So remember, when you factor it out, it means you are dividing the terms inside by the number that you take out. So 2x squared divided by 2 is x squared minus 7 divided by 2 is 7 over 2x. Don't change that to 3.5. It makes it a little bit harder to work with. Right? But if you do change it to 3.5 and you want to use calculators, it's fine. But I would prefer that you all don't use the calculators for it because it takes some extra time that you don't need to use, right? So let's just write the perfect square formula here. Right? So when you're doing the perfect square as you're learning it, just rewrite the formula on the side so you know where you're going with it, right? So inside the brackets now looks like these first two terms, x squared, right? Don't worry about the symbol addition, right? This is still add negative 7 over 2, right? B is 7 over 2. So now we are looking to find 7 over 2 squared, right? We need to find a half of 7 over 2, sorry, right? So 7 over 2x plus, let me write out the whole thing, a half of 7 over 2 or 7 over 2 squared. So this number, right, divided by 2 and you're squaring it. And whatever you add, you also have to subtract it. So this becomes minus 7 over 2 squared. And then you have this plus 4 outside here. Now these first three terms always collapse into this here by this formula. Now, if you're unsure how, just drop back a few videos, right? I don't want to take too long on explaining that. So that becomes x, and this number here is minus 7 over 4 squared. And similarly, this is 7 over 4. 7 squared is 49, and 2 over 2 will give you 4, and 4 squared is 16 plus 4. Good. Now, this will give us 2. As we expand now the brackets here, now you take 2 by the inner bracket, so 2 into x minus 7 over 4 squared, and then 2 by 4. Now this is what I doing these couple questions for, to show all of the fractions. So we want to see what is 2 by 49 over 16, as this external 2, when we expand the brackets, 2 by 49 over 16. Remember, the 2 and the 16 will cancel because this is technically 2 over 1 by 49 over 16, which will give us 49 over 8. So this number becomes minus 49 over 8 plus 4. Now this number here, you can put it in a calculator, it's fine, right? Now for smaller, like for larger numbers, you can probably put it in a calculator, but for smaller numbers, my advice is always to check what you can do, right? When it's a whole number and you're adding it to a fraction, multiply the 4 by the 8, right? So that becomes 4 eighths 32. But then you also have to divide 4 by 8 to balance it off. So now these are two nice, easy fractions that you can work with. Now this is an alternative technique. If it is you don't want to use the calculator, by all means go ahead and use this technique, right? So negative 49 plus 32 will give you 17, right? So this here is 17 over 8, and that's the answer. You can leave this as an improper fraction. So let's go with number 2 now. Number 2, we're doing the same thing. So let's go with a little bit more challenging one again. Step it up. So 3x squared minus 5x minus 2. Now, negotiate minus 5x minus 4. All right, so let's see what this will look like. So same thing. You first need, if you want to use the perfect square formula, write it down. Right, so let's put it on the side here so you know that that's what you're looking at. First of all, we want x squared, the coefficient of x squared, to be 1. So you divide throughout the x squared terms by 3. So put the x terms, in brackets, divide both of them by 3. So you withdraw that 3 and divide by 3. So this becomes 3x squared divided by 3 is x squared, minus 5 divided by 3 is minus 5 over 3x minus 4. Good, now next one now. You want to make the inside of these brackets, the x terms, look like this. So you need to get 5 over 3 over 2 and square that. So 3 into x squared minus 5 over 3x. Whatever is the b term, you add on b over 2 and square it. And then you also subtract b over 2 and you square it. Again, you subtract it to balance off the expression. And then you have our subtract 4 outside here. Right, so now, according to this formula, x squared plus bx plus b over 2 squared, that will always break down into this. Right, if you're not sure how, drop back about the 2-3 videos that you'll see it there. So this now becomes 3 into x squared x, right? And whatever number is inside here, or you could look at a half of this. A half of minus 5 over 3 is minus 5 over 6 squared. And now this number here, now I'm going to write this on the side. Minus 5 over 3 over 2. Right? This is the same as saying a half of minus 5 over 3. And that is minus 5 over 6. And now when you square that now, you get positive. So that's minus 5 squared is 25 over 6 squared is 36. So this becomes minus 36, sorry, minus 25 over 36. Right, minus 4. Good, we're almost done. 3 multiplied by the first bracket is 3 into x minus 5, 6 squared. And 3 by 25 over 36, the 3 and the 36 will cancel to give you minus 25 over 12 minus 4. Now again, this number outside here, you could easily work that in the calculator if you want, or if you want to stick with improper fractions, check what you can do. 3 into x minus 5 over 6 squared minus, you multiply the 4 by 12. Right, so that gives us 48, but you can't just randomly multiply 4 by 12, so you divide by 12 as well. Good, so now you have minus 25 minus 48, and that will give us 73. So it'll be 3 into x minus 5, 6 squared minus 73 over 12, and that's the final answer. So this is how we do these questions, and this is one of the harder ones that tends to come with the more mechanical version of completing the square. When I say mechanical, I mean It's just standard. It's nothing too difficult. They will most likely tell you, rewrite this expression in the form of this, right? But we will get to that in a little bit and what that form really means. So 2, number 3, last one now. Let's go with, this one is one of the harder ones now, minus 2x squared plus, let's go to a smaller number, plus 3x minus 1. And that might actually work out. Minus 2x squared minus 3x minus plus 1. Right, so let's go plus 1. So let's see what we're doing here. So again, you need this formula here. You need this form first. All right, so you need x squared by itself. Well, the coefficient of x squared must be 1. Right now it's negative 2. So if I throw my square brackets around this and I take out this negative 2, right, what I get is negative 2x squared divided by negative 2 is x squared, but positive 3 divided by negative 2 is minus 3 over 2x. Leave this plus 1, leave the c term outside here. You notice we don't use that until literally the last 2 lines. Now, this looks something like this form here. So we need to get a half of minus 3 over 2 now. So you're only looking at the x terms inside here now. X squared minus 3 over 2x. You are adding on minus 3 over 2 squared, right? Because that's what we need. We need b over 2. B is this over 2 squared. And you, to balance it off, you subtract minus 3 over 2 squared. And then you add 1. Now, these first 3 terms up to the added term give you the perfect square. Right? What is the perfect square? To be a half of minus 3 over 2, which is this number, which will give us x minus 3 over 4 squared. And this is also 3 over 4. So 3 over 4 squared will give us minus 9 over 16 plus 1. Good. And now we just expand. Negative 2 by the first brackets is just that. Negative 2 by this is negative 2 into x minus 3/4 squared. And now negative 2 by negative 9 over 16, as here now, will give us negative 2 by negative 9 over 16 will give us positive 9 over 8, right? Because the 2 will cancel with the 16. And then this is plus 1. Now, if you get comfortable with doing the improper fractions in your head, you will know that this is 1 by 8 is 8. So this will be 8 over 8. 9 plus 8 is 17 over 8. And that's the answer there. Right? If you're unsure how I got this here, feel free to put it in the comments, right? And we will check it out there. But this is it. This is completing the perfect square, right? So if you have any questions, feel free to ask in the comment section. Also, um, well, I didn't say it for the last few videos, but after each video, well, I will have one overall worksheet for the entirety of quadratics, and I'll post it under all the videos anyway. So, but it will cover each of the sessions. Session 1 will have its own worksheet, session 2, session 3, session 4. So all you have to do is look for the session of the worksheet which says session 18. Right? So you will get to see what is the questions that I will put for these there. Right? So practice those questions and I know that you will get them all. But importantly, practice these questions. You see the examples, do them first. Make sure that you can master the examples because you have live, well, essentially live assistance here, right? So pause the video on number 3. Try to do it by yourself and then go through the steps and see where you make a mistake with each one. And that's how you learn. You don't learn by just doing your homework only. A lot of people forget that the examples are questions as well. So the examples are not to watch. They are also for you to try them out too. Right? So that is it for this video on completing the perfect square. We are actually finished now with completing the perfect square. In the next video now, we will go on to developing a formula that works with completing a perfect square and what that has to do with curve sketching or sketching the quadratic curve because that's we did 3 videos ago. So until the next video, everyone, take care and I'll see you all then.